been working quite a few years on the Sage project, and the Sage project has had, woohoo, Sage Math Cloud, go them. We've had interactive widgets for about the last 5 years or so, and so I've been working on those for about the last 5 years, and then was really excited when Fernando and the IPython folks to do a widget system as well. So I've been helping them design and implement the IPython widget system. Now, just so I understand my audience better, how many people here have used the IPython book? Okay, great. And how many people have used widget at some point? Okay, quite a bit less, but maybe excited about it today. So the idea behind widgets is we want to solve this problem of the feedback loop in computation. So typically in computation, we design or model a real-world phenomena of some kind, and then we program up this model, and then we run the model and have some results, and then we realize our results aren't exactly what the real world was, so we change our model, and then we program it up, and then we visualize the results somehow or look at the results somehow. And this feedback loop is really quite onerous sometimes, and it takes a long time. And so by the time you want to run you have the computation, and say you want to run a variant of the computation by just up to the code, reevaluate the code. Let's see. Yeah, where's the speakers? Yeah. Oh, that's okay. Maybe if I stand over here, it'll be better. All right. So what the widgets are trying to do is make this feedback loop between adjusting a computation and visualizing the results much faster than editing code and rerunning code, etc. Instead, we can drag a slider and get this loop almost instantaneous, or at least as fast as the computation can run. And so we can play with parameter values quite a bit and then adjust our model if we need to. The other reason we like widgets is because sometimes people don't like to program, right? We're doing a system and we're trying to show it to our boss or the salesperson or whoever. No offense to salespeople, but it's really nice for an end user to be able to adjust a computation, adjust parameters in computation by just dragging a slider versus going up to code and figuring out where the number is and editing the code and rerunning a computation. So the big idea behind widgets is we've got paired Python and JavaScript objects that sync a set of data. So you have a Python object and a JavaScript object, and they share some attributes that are automatically synced back and forth. What this means is your back end and your front end share a set of data that can change. It can change on the front end and automatically reflected to the back end, and it can change on the back end and automatically reflected on the front end. On the JavaScript side, we have this data, and then we can render views of it in different ways. So we can have multiple views of a JavaScript model and in different cells or different ways of representing it. And so we have a single model, multiple views on the JavaScript side. And the views typically are the things that we see, and they live in a special area above the IPython outputs. Okay, so here's an example. I'm going to make this a little bit smaller so the code fits a little bit better. All right, if I may, can you read this? Okay. So what we're doing here is we've got a float slider widget. This is just a slider. If I run this cell, you'll see its initial value is 20. By default, the min and max are 0 to 100, and description is this little label right here. And you notice I printed something even before I displayed the slider, but because widgets right now in IPython always show up at this area above the output, they have the output appearing below the widget. And so you can see I can move this slider around, and I can change it on the front end, on the IPython notebook side, the JavaScript side, and then in the Python side, that was automatically reflected back to Python, and the value of x, so we're saying x is the float slider widget, the value of x is 65.5, what we've done. And it goes the other way too. We can change the value here, and it reflects a change in the slider. So this means you have programmatic control over your GUI that you're building in the front end. And you have automatic input from that GUI in the back end. So we have more complicated objects, widgets. Widgets can contain references to other widgets, and widgets can trigger events. So here's an example. I'll even put this on the next line. So we're going to create a widget, a text widget. It says, hi, Mom. Hi, Mom. button widget that has a label of leave, and we're going to define a reset function, and then we're going to do something with that reset function. So first of all, when we evaluate this cell, we get hi mom, and then the button. And notice this container widget here, it has a reference to two other widgets. So we can nest widgets inside of each other. And this turns out to be extremely powerful when we talk about really complicated systems of widgets later. This reset function, you notice that I can set any value of these GUI controls on the Python side. It'll automatically be reflected on the JavaScript side. Question?
So we love the widgets and the text box. We'll use the text box for saving a save file location. And one of the issues we've been having is that every time you change a character, it adds. So you have this like huge directory of one character.
Yes.
File names. So can you use this reset then to have like a save now button instead of saving 20 different files?
Yeah, good question. So the question is, sometimes we get into trouble when we try to reflect changes from JavaScript to Python, and sometimes we do it too often. So for example, with the text box, every time I type a new character, it sends that value back to Python, which is bad if you want the whole string as a single object. We're fixing that for IPython 3.0, I think. You have to make a change on the JavaScript side in order to say don't send changes as often. And if I remember right, the text widget for IPython 3.0 has this option. If not, we can backport it. Well, IPython 3.0 is supposed to come out any day now, well, maybe any week now or any month now. But we can backport that. Talk to me afterwards about that. All right, so what do? We set the value of the text box to goodbye mom, and then we change the children of the form. So we're going to delete one of the controls. Now, alternative, what we could do is we could just make the button invisible. But what is the effect of this? We say hi mom, we press leave, and the button disappears because the form references the B has now disappeared from the children, and the text value has changed. So you can see you have lots of control over this GUI. One cool thing, so this is something we've done in Sage for about 5 years now, and Brian Granger worked it with the IPython widgets, automatically guessing a GUI. So you have some arbitrary function. So here's a function, I think this is from Brian actually. It just computes two waveforms added together. Let's see right here. We add the two waveforms together. And what happens is you get some beating. So this is, for example, a tune with a tuning fork. And so we just have this random function that we've done. And we want to automatically visualize it. And so we do this interactive. We give it the function name and then tell it for each parameter what are the values. And it automatically guesses a GUI control, or you can specify a GUI control if you'd like. Automatically guesses a GUI control. It says, F1 and F2, they look like they're ranges of floats, so let's put a slider in there. And now as we adjust the slider, you notice that it regenerates this. It reruns the function every time the input parameters change. And so, when you're tuning the piano, can you hear this? There's the beating of those frequencies. If you get even closer, then you hear it's going woo, woo, woo. And so you can play with this. I work at Bloomberg now, but I moved to Bloomberg in June, and before that I was working as a math professor at Drake University. And these are amazing in teaching, to be able to give students easy controls, easy to design controls, right? A professor, all he has to do is write this stuff, and then just call it interactive, and boom, the student can play with it. It's also great on the job when you have somebody, you want to show a result, but you don't want to show all this code, etc. Bam, there's a GUI that someone can play with. We can also trigger events. So you notice that we have this syncing back and forth, changes, but every time a piece of data changes in a model, we can trigger an event. So on the Python side, we use traitlets, which is modeled after the nthought traits from quite a while ago. And on the JavaScript side, we use Backbone, which is a standard JavaScript framework for models and events and things like this. And so what are we doing here? We create a slider widget. So this time it's an int slider widget from 0 to 100, default value of 30. And then we want someone to be able to see the square of this. And so we construct the latex widget. And the latex widget uses MathJax to typeset your LaTeX. And the value is going to be the square of the value of x. And anytime things change for the slider, I want it to reset the value of the text box. And so how do I do that? I define something that will have the effect that I want, here resetting the value of the text box. And then I say this is using the traitlets, which is modeled after the nthought traits. X.onTrait change, I'm going to execute this function when x's value parameter changes. And then I display it. And what you see is anytime I change the slider, I change the slider on the JavaScript side, it syncs that value back to the Python side. The Python value changes, and the Python value change then triggers an event. It triggers this callback right here, and it resets the text box. And so you end up being able to do complex interactions between things and complex effects based on this triggers of any of the data changing. We can do more fun things with that. We can link together widgets. So this triggering is really nice. And sometimes you want values to be exactly mirrored between widgets. You want to keep two widgets in sync. And so we abstracted out this event mechanism to a simple function, a link function in traitlets. OK, so what are we doing here? I import the link function from IPython. I create two sliders. First slider is a value. The second slider is supposed to control the max of the first slider. So I'm setting this slider right here is controlling the maximum of this slider right here. And how do I actually hook that up, make that interaction work? I'm using this link. I say link the max attribute of the x, which is this slider, with the value attribute of the x max, which is this slider. You can hook any two attributes to each other. Or you can hook 4 or 5 attributes all in a row. You know, all these 5 attributes should be kept in sync. So what's the, OK, so we have x, it's changing, right? And if we change the max of x, you can guess what happens. All of a sudden, that max goes down. So say we change the max down to 72, now you see the max is 72. If we change the max less, then the max is now 61. So we can have pretty easily sort of really complex interactions here just by linking up. You know, I want whatever the slider is, I want its value to show up down here. So I link the text box value and the slider value. We can actually, so this is happening on the Python side. Sometimes the lag of sending a value back, changing another value, and then sending this value back to JavaScript for the other slider, sometimes that lag is kind of onerous. So we can actually push this link to the JavaScript side. You have to write some JavaScript code, and we've got a pull request in for this, and we're debating if it belongs in IPython or in a separate library. But we could hook things up on the JavaScript side using the backbone events. And in that case, you know, these two are kept in sync in the JavaScript, and then both of their changes are mirrored back to Python. One of the things, though, this emphasizes is where data should live and where events and things like that should live. Notice, no matter how many times I display these two sliders, different views of the same model, I still want them all linked up. And so this event that I want to have happen really is an event linking two models together. So remember I said we had two different objects on the JavaScript side, a model and a view. So a model has possibly lots of views. And this is the sort of thing we want to put in the model, because we're hooking up two attributes. We're hooking up two models. Other times, we want to put events and effects and things like that in the view. And one thing that I've learned in working with these things is just a simple thought process is whatever I'm doing, does it make sense for it to happen every place this thing is displayed? If it does, then make that effect happen in the model or put that data in the model. Or do I want this effect or whatever I'm trying to do to happen in one view, but not affect other views? In that case, put the effect in the view. So this comes when you're writing the JavaScript code for widgets if you want to do custom widgets. All right, some more advanced stuff. Distributing widgets. This is a problem that we have not solved yet, but lots of people are experimenting. For example, somebody at Quantopian released not a widget, but it's something similar to a widget, and came up with this formula. And there's been other people that have released widgets with this sort of formula, and it seems to work out well. Remember, you have Python and JavaScript code that you need to somehow communicate JavaScript code to the front end, Python code to the back end. So one way to do this is to package up both sets of code in a Python package, just a standard setup tools package, and then make inside of your package an install the extension. What that does is it calls an IPython function that copies the JavaScript or links the JavaScript into a standard place for user-defined JavaScript in IPython. And so you distribute a Python package, you have a function that the user has to run in order to copy the JavaScript code over to IPython. But it's just one function. They don't need to know anything else. You just run that function. And then, but there is one other thing. You have to somehow tell the IPython notebook to load that JavaScript code. It's now it can find the JavaScript code, but it doesn't know how to load it yet. And so you have to add some stuff to the IPython profiles custom.js in order to load that JavaScript code. This is changing for IPython 3.0. And IPython 3.0 will be able to automatically load any widget JavaScript code based on some metadata in the widget. So the third step will disappear in IPython 3.0. One other thing that you'll notice when you're designing widgets and things like that is this syncing that happens back and forth between JavaScript and Python is done in JSON. So how many people are familiar with JSON, the data interchange format? Yeah. So it's wonderful and great, but it's not very rich, right? All you've got is lists, strings, floats, dictionaries, things like this. But it doesn't have like NumPy arrays and pandas data frames and images and whatever else. And so one of the things you can do if you design your own widget, is you can do custom serialization. So you can say my widget has like a NumPy array. Well, I can't send a NumPy array directly over JSON to the JavaScript front end. So what I can do is when I design the widget, I can say this is how to convert this particular value, this particular attribute to JSON. And you do this using the from and to JSON. If you want details on this, come talk to me afterwards. Change Python 3.0. So the first one we've talked about, basically you don't need to pre-load JavaScript code. It can load JavaScript code on the fly. One of the other things that you notice if you start designing widgets is that when you have widgets that have references to other widgets, it gets pretty complicated, like keeping track and keeping lists in sync with each other. And we're going to make that a lot easier using something called a view list in IPython 3.0. We're working on persistence. Right now, if you save the notebook and open it back up again, the widgets are gone. In viewer, widgets are gone. And we're working on being able to save widgets so that if you open it back up again, the widgets are still there. You don't have to re-execute the notebook. And we're changing a bunch of names. This has actually already happened in Tree. Container widget, for example, goes to box. So it's a little awkward. OK, one last thing. One of the things I worked on quite a bit on a grant for Sage with students at Drake University where I was teaching was to write 3D graphic rendering for IPython notebook. So the idea here is we've got a pretty standard, pretty comprehensive WebGL 3D graphics library on the JavaScript side called 3.js. And we want to wrap this library using widgets so that we can manipulate any part of a scene from Python. So the basic idea here is, really basic idea is we have a bunch of objects on the JavaScript side. We figure out which attributes we want to expose. And we wrap them in a Python widget. So each Python widget corresponds to a JavaScript 3.js object. And then when we render, what we do is when we display a Python widget, it goes over JavaScript side, and it creates the corresponding object and adds it to a scene graph. So what happens is you don't actually see in the HTML page all of these things that are being rendered. There's scene graph nodes and a 3D scene graph. But they're being collected into a single 3D scene and then rendered. Here's an example. Let's see. So in this example, I create basically a surface by creating the z values. I create a surface geometry. This is one of these objects. Here's the z values and some other parameters. I create a mesh by taking a geometry object and and some sort of material that can be pretty complicated. Here it's pretty simple. Now I'm creating a scene by taking that surface and a light, and I'm adding to that surface also the wireframe lines, so a mesh grid of some kind. I'm wrapping it all up into a scene. Then I'm adding a camera to the scene. I can adjust any parameters of the camera. And then I render the scene and add some interaction controls here. And the result is 3D graphics in the IPython notebook. And this is 3D graphics that I can control any part of this from Python. And I can change the light around. I can add a picker that tracks the motion of my mouse cursor and then reflect the current coordinate back to Python. I can even have a camera widget that takes a picture of your face and then creates a texture and puts your face on this 3D object. The possibilities are endless here. All right. The pythreejs code is up on GitHub. Right now it's in a state of flux because I'm trying to prepare it for IPython 3.0, so it may or may not work. But it's all up if you want to see a really complicated example of a system of widgets that are all interconnected and linked together. All right, thank you. Do we have time for questions? Whoever's in charge. I'll post this notebook up, sure.
So an IPython widget runs on an IPython notebook, right?
Yeah.
It does not run in the browser.
The IPython notebook runs in the browser, so it's transitive here. So the widgets do run in the browser, but they need the IPython infrastructure in order to run.
Can you use, like, where does JavaScript come in? Like, can you use JavaScript from Python or like?
So are you asking, can I get these to run on just like a normal web page instead of the IPython notebook?
About writing JavaScript,
but
how do you use JavaScript from IPython notebook?
Okay. So there's a couple of different ways. You can distribute a file of the JavaScript, copy it into a special location, and just call it from your IPython notebook server. Or you can do what I did down here when I was preparing this. So there's a bunch of initialization codes here, and you notice this right here. You can make a cell with a % JavaScript, and just put all your JavaScript code in there if you really want to. So you can just distribute a single IPython notebook that has a bunch of code in cells, JavaScript and Python.
So you can call JavaScript.
What you can do here is basically send this snippet of JavaScript to the front end, and it'll be executed there.
And can you change JavaScript variables from IPython?
Not as easily, though Jonathan Frederick worked on something that lets you do that using widgets. So there's some pretty interesting capabilities there.
So I'm new to the subject, but anyway, can you keep the coordinates and start from the widget and show me the way how it gets to the
I'm sorry, start from the widget and?
Start from the widget and go back and show every step how I got to this widget.
With the widget or the specific values that are in the widget? Yeah, so because all the changes are reflected immediately, and because you can hook into events into those changes, what you could do is write a function that stores. Every time this widget changes, store its value in a database. And so that way you could create your own provenance system where you're tracking every single change of these widgets. And then you can replay them and everything. I think that would be a cool feature to see actually in IPython. Or at least the idea of being able to set bookmarks or of some kind.
So far, it's a custom widget, so
Yeah.
I need to write my own.
That's right. That's right. Okay, so yes, yeah, right now can we do it? There's built-in IPython stuff. We can't save changes right now with built-in IPython, but you can build your own and contribute it upstream. I'd love to see it. I'm gonna say, any other questions? All right. Thank you very much. If you want more information, feel free to go on the IPython user list and ask questions. Feel free to contact me directly or Jonathan Frederick, who's the main author of the IPython widgets, or Brian Granger, who's the main author of the notebook. We're happy to help, and we'd love to see a lot of exciting advances in this area. Thank you.